Right, today we're going to do this question. This is from OCR A 2020 Unified Paper 3 Chemistry. And it says the equilibrium constant Kp at temperature T in K Kelvin are linked by a mathematical relationship shown in equation 5.1. R is gas constant and delta H is enthalpy change in joules per mole. Okay? So it says this is the equation they give it to you. L and K equals minus delta H divided by R times 1 divided by T plus delta S R. Okay, so that's the first thing they give you. So now they say the table shows values Kp at different temperatures for an equilibrium. Complete the table by adding the missing values of 1 divided by T and ln Kp. So all I did, this is 1 divided by T here. I just put 1 divided by 400, 1 divided by 500, 1 divided by 600, 1 divided by 700, and 1 divided by 800. So they gave me those values there. Okay, and then it says ln Kp. So it will be, you just do the ln or the values Kp. So you do ln of this, ln of this, ln of this, ln of this, and ln of this. So that gives you those values there. Now, so the next bit here shows the temperature. Is a state and explain how increasing the temperature affects position of this equilibrium and whether the forward reaction is exothermic or endo. But look for this equation here, you can see it's a negative charge here. So I assume it's an exothermic reaction. So if you increase temperature, equilibrium position shifts to the left-hand side as the forward reaction is exothermic. So that's the answer to that question. It's only 1 mark. Okay. Now we're going to move on to C. So plot a graph of ln Kp against 1 divided by T using the axis provided in opposite page. It says use this graph in equation 5.1 and determine delta H in kilojoules per mole for this equilibrium. So give your answer to 3 sig figs. So what I did first, I plotted a graph. So you put the graphs at the points that you have here. So you got 1 divided by T here, the values, and then you got those ones ln Kp there. Okay, so they gave me the line of best fit there. So the cross is there exactly in the points it is, and that was the line of best fit. So the next thing they ask you is, work out delta H. Okay, so the workout delta H, I just did, I worked out the gradient, which is 75, the difference. So I use 75 here, 75 divided by 0.00125. So the gradient is actually minus 60,000 joules. And then if you multiply by R, because the gradient times R is going to be the enthalpy change, because what I did here is that if delta HR is the same as minus EA over R, which is your gradient. So if the gradient is the value that we got times R, you get delta H. So the delta H is worked out in here, okay? So you can see ln K equals to this times this plus this, mxc, sorry, the x is a bit weird. Then m is a gradient, so we already have to take the gradient, okay? And then you got x, which is 1 divided by t, and c is the intercept in here. So if you take the gradient here, which is 75, which is the difference from here minus this, and then you have difference between that minus that is our value there. Okay, so it'll be 2.5 times 10 minus 3 minus 1.25 times 10, because it goes here, 1.25 times 10 minus 3. And that will give me, what does it give me here? 0.0 something, okay? So the difference is that then you take the gradient, gives you 60,000 joules, okay? So minus 60,000 joules, multiply R gives you delta H, and then you get the delta H is minus 498,600. And then you change that for delta H in kilojoules, which is minus 498.6 kilojoules. And then you change for 3 sig figs as they ask, and it gives you minus 499 kilojoules per mole. Okay, so that's how you work out delta H for that. Now we're going to do this one here. Explain how delta S could be calculated from the graph. Okay, So how did I do that? So you go to, again, the reaction, the equation here. So I just replace the values to that. So we worked out your gradient here. We know ln K is 135. If you look at the graph here, is the last point here is 135, okay? And then you multiply that by 1t, which is here, and plus delta SR. So I rearrange this equation and gives you ln K minus 60,000 times 2.5 times 10 minus 3, which is your 1 divided by t at that point there, okay? So that'll be this one here. And then once you've done the calculation, the ln K is 135 minus 150, it gives you minus 15, okay? So the delta SR is minus 15. That's how you work out the answer. It looks very complicated, but I think if you follow that thing in there and you just say mxc, and you know this is your gradient, okay? So you can work out gradient by using these values, and you work out gradient, you'll find a delta H value there. You know that value, and then you can rearrange the whole lot because you got ln K on your graph, you got that delta S there, you rearrange all of it to find your delta S divided by R, which gives you that one there. And if you really want to do, you can multiply by R, okay? And you get delta S for that question. So that's how I did that question. I hope that is helpful how I did it, because the mark scheme is not very helpful to explain, but hopefully you get it a bit better for this question. Just attempt at home, attempt to do it all yourself, see if you can understand that. Thank you.